Felipe Vicens. I work for Atos. I am a member of the ETSI of Open Source MANO. Today I'm going to give a presentation about slicing our network service. So basically what we are going to do is to get some concepts about the slicing and how to create a slice for the service that we were working on this week. The first reminder, we have 2 new instances for you. Please check the column new instance in the spreadsheet because we made an effort to split the participants into 2 instances in order to avoid any issue for that we could have today. So some of you will be in the .41 and others will be in the .57. So please go to your server and then to execute the hand-ons part of this presentation. Okay, let's start with the overview of network slicing. So in the networks today, we want to apply some kind of rules in order to divide the service that we are creating for the telco, the end-to-end network service, and in some cases the network service itself requires different characteristics in terms of latency, in terms of bandwidth, in terms of reliability. So here is the point where slicing comes to help, no? And with the slicing, then what we are doing is creating a portion of the network in order to deploy our network service and then apply some characteristics there to guarantee high throughput, low latency, or even a specific property for IoT, okay, that require massive devices. So if we look at the standards, we have a 3GPP and ETSI. The most important characteristic that we have defined in ETSI is that you can have a network slice subnet. This is a concept, a very important concept of the slicing. This network slice subnet is basically what we know today as a network service. So in a slice, we allocate a network slice subnet using the network service that we have, and then we can have multiple network slice subnets connected together to form what we want to do, that is the slice. So at the end, the slice, one of the important characteristics that is described here is that the slice allows us to do network service composition. That means that you can connect your network service inside a network slice subnet, okay, and create networks among them. And this gives us a second characteristic that I think is very, very important also, because sometimes you need to share a network service because some reasons you need to you cannot afford pay one license per network service, so you can share that. You don't want to replicate multiple times the core, okay, but you want to use only one. So this important characteristic, since it is the sharing network slice subnet, is something that is present for the network slicing. So in summary, we have two things, two important things. That one is the network service composition, that is provided by the SLI and network SLI subnet share. We will see at the end of the presentation, at the end of the hand-ons, we will create the Magma orchestrator as a shared network SLI subnet, and then we will have multiple Magma gateways in order to share our orchestrator among the multiple Magma gateways that we will have. So our slice will look like this. So we have one network service that will put as a network slice subnet inside our slice, that is the red box. And then we have another network service that we lack as a network slice subnet. This is the second one. That will be the evolved pack core with the Magma virtual EPC and emulator plus the PDU. We can also include PDUs here. Okay, so at the end we will have a slice with a Magma orchestrator as a shared network slice subnet plus multiple instantiation of network slice subnet that is not shared in our case with the evolved packet core network service. So the goal of today is to build this network slice template. The template is previously instantiation. When you instantiate a slice, then it will be converted to a network slice instance. This is the terminology that we use here. So the template is something that you model, and then when it is instantiated, it will be converted in an instance. Some of you have a question? Okay. So, okay, our network slice template will contain a network slice subnet with the faithful Magma network service, a connection point from the network service to VLD. This is the way that we do the network slice network service composition via this kind of virtual links. Okay, and then we have also other network slice subnet that contains the Hackfest Magma access gateway NOP network service descriptor through its network service descriptor connection point management. You do these connection points yet, but the package that are already in the repo contains the network service with the connection point in order to to create the slice, okay, the network service composition, because you have to expose the connection point in order to connect with the slice VLD management. This is the management interface for both. If you have multiple data centers, the connection, the networking, it will be also when you have shared instance, then the networking will be connected all together. So this is something that the slicing also helps here to create this the network slice composition. So and the requirements for this session is to have the BNFD that are located in the repo, the faithful Magma KNF, the Hackfest Magma BNFD, and the gateway, that is the PDU, plus the network service that we will compose, the Facebook Magma network service descriptor plus the gateway. Also, you have here a link to the Magma slice YAML. This is the one that we will use during the session. So you know now pretty well the composition of the BNFDs. This is the Facebook Magma showed yesterday by Gerardo. As you can see here, is a pretty complex KNF. It have a subchart for a Postgres for database. It have a subchart also for MySQL. It have a subchart for the orchestrator, and also well, it's not a subchart, but it's part of the chart for the orchestrator, plus the web page that is the NMS. Okay, so all these components are at the end one BNF that will model as KView. Okay, and well, you are deploying all the time this, but as you can see here, it's a very big and complex function. Okay, this is the network service for that Facebook Magma orchestrator. Basically, have connection point management through a VLD. This can be modeled as a switch, okay, and then another connection point to our network slice template. Here we have the VNFD for the Magma gateway. I'm not going through details. But well, in the network service, the important thing is that also have a connection point exposed from the network service till the network slice in order to connect both and create the network service composition. So at the end, you have the connection point from the network service one is a net slice subnet slice Hackfest NSD management. This is the orchestrator. NSD connection point management from the second network service, that is the net slice subnet slice Hackfest NSD EPC. Fine. How can we create the network slice template? Okay, in the modeling process, you can differentiate three big blocks. The first one is the definition of your network slice template that you specify here the ID, the name, quality of service, and ID. The other is the net slice network. You specify the network services, okay, if it is shared or not shared, and the net slice VLD that are the switch or cables to do the network service composition. So this is coming from an information model that is available to review and to check all the options that are enabled in OSM. So if you click here in this link, then you can see the information model for the network slice template. So the first part, as I was telling you, we have some parameters here, like as a identifier for the slice service type. As we saw in the second slide, we had some kind of slice, so we specify here the type. It can be MBB, but also it can be another for latency, or like this about the bandwidth. It's important to note that in this modeling process, currently in OSM, this parameter is not enforced in the infrastructure. We are looking for models to enforce these kind of parameters, but it's not something simple, and it's not currently is not supported by OSM. The enforcement of the service slice service type and the quality of service over the infrastructure. These parameters, if you read the network slice template and say, okay, the service that contains my slice require a service type. It's a service type EMBB. So I am going to deploy it my network slice instance in an infrastructure that support this type of service. So it's something that you can do manually, knowing what kind of service are you modeling inside your template. Okay, in the future, probably we will try to enforce this kind of parameter, but as I said, it's not so simple for the time being. It is just a reference, okay, that you put here for the operator that will deploy the slice, know which type it is. The the second big block that we have for the slice template modeling is the network slice subnet. So as you can see here, we want to include our two network services. So we create two network slice subnets, one for the orchestrator and a second one for the gateway. Okay, and we need to put here the network service descriptor ref. That is the ID of the descriptor. I think I have it in. No. Okay, this is the ID of the descriptor that you can find in the network service descriptor. The other important point here is the flag is shared NSS, because when you have multiple instantiation of the same template, then this network slice net will be shared. Okay, so this flag indicate that the network slice net will be shared. So in practice, in the hand-ons part, we will have the orchestrator shared, and the other ones will not be shared, so it will be not deploy. It will be deployed again each time we instantiate and we create a network slice instance from this template. Last part is the NetSlice build section. This is where we do the network slice service composition. We create connections between among the network slice subnet. So basically, we are indicating here that we want to connect the NSD connection point management with the network slice subnet reference that we have here. This network service descriptor connection point reference belongs to the network service descriptor. We can find in the network service descriptor what is the name of the connection point there, and we do the same for the other network service descriptor, and that is for the orchestrator, and then we make the link here. Okay, so also this have the is management network flag to indicate that this will use the management network of the beam. Okay. Any question until now? Please write it in the chat. Okay. So I have prepared here a script for the session, but I will comment you something before. The command, well, basically these are the commands that you can use to onboard the package required and the slice template required to the OSM system and to instantiate instantiate the network slice instance. So let me check the question from the chat. Okay, VI. Is OSM expected to impose QoS policy from NST on the bin? The answer is no, it's not expected today. Probably in the future, it will be mechanisms to do that, but today the QoS parameters and the flag is just a reference for the ones that want to deploy the network slice template, or to say, okay, this VM will support this kind of QoS. I will deploy there. Okay, it's something that we don't enforce today via the orchestration. Okay, it's not an automatic mechanism. Okay, you're welcome. Yeah, the command to create an slice instance from the template is OSM NSI create. As you can see here, we have a lot of options that you should put it here. For instance, NSI name is the name of your instance that you will create. Okay, the NST name is the name of the template that is uploaded on board to the OSM. The bin account is the default bin account that will be used to deploy your service, your slice. Okay, you have optional parameters like SSH key, config, and config file. You can pass this configuration from the command line, but it's recommended procedure that use the dash config file and put the parameters here, because sometimes it's difficult to compose in JSON in the command line with all the options without made errors detect for the config. So I really recommend to use the config file as a YAML and instantiate your slice using the config file. Okay. Other question. Okay, let me check the chat right now. Joe, will it be the end-to-end QoS that will apply run slicing to an network service? Yeah, probably. This is something that that can land in the future when we have a slicing, and then enforce this kind of QoS parameters. Let me go a bit up to this part. So here in the information model, well, we have a set of parameters. One is the one that you comment, the 5QoE is a standard for 3GPP, and this is the ID, the reference ID that we put here. But currently it's not enforced by OSM. Probably in the future it will be enforced, and we will find mechanisms to do it. But nowadays it's just a reference for the operator that will deploy this network slice template to allocate the hardware and in the right beam and use the right beam to perform this operation. It's not something that happens automatically. Okay, Ankasha, where can I find the maximum slice? Thank you, George, to provide it. Okay. Okay, so for this instantiation, we are going to use the params slice.yaml. We have an automated script that I will show you in the hands-on part. Okay, for this instantiation. So please wait some minutes till we get there. This script have some optimization things that we need to do it okay to run it quickly. But okay, the parameters slice YAML is the file that I'm going to inject with the option dash config file, and as you can see here is a YAML with a lot of parameters. The thing is, we want to influence in the deployment of the network slice .NET. So in this case, in this particular case, we want to use force these additional params for the VNF and to specify what are the configuration used by the primitive, okay, to configure our gateway, and also in case of the orchestrator, we use the we also want to enforce parameters for the deployment of the Helm chart, that is a proxy service load balancer IP that we want to change in order to both connect together when I trigger a slice. So previously, when you were launching your network service with a script, as you remember, you instantiate a network service first with the orchestrator, wait some seconds, and then instantiate another network service with the gateway, okay, passing the IP that you put here for the proxy service load balancer, right, to register the APC there. But since it is a slice, and both network slice .NET will be instantiated together, it is not necessary to instantiate one or not two, but we need to manage or influence the deployment of your network slice .NET to specify, okay, this parameter have to be pass in instantiation time and configure. So let's move to the Hanon session. Let's make some checks before that. As you can see here today, we have a list of projects, okay, located to one new OSM instance, and then we have other list, okay, for other tenants located to a second OSM instance. I hope this helps for today to not have an issue, okay, and to have a backup just in case. So I am connected to my tenant, the instructor tenant. So the first thing that we should check is if we have the Vim already there. Okay, so it's OSM Vim list. So I have it. I have this one. Okay. That is correct. I'm also going to OSM Kate's cluster list. So also have a cluster connected. Okay, and the package OSM NS package list. Have the network service and the functions and the network slice template. So you will need to have all these three things. How can we do that? Okay, if we go to the folder HF scripts, we have to run first the recovery infra. This script basically will create for you the Vim with the right name, using your environment variables with the OSM user, the password. Okay, this will create your Vim. Then it will create a Gates cluster for you using the Vim name that was provided before, and it will create a PDU. Okay, that is a requirement for this session, since we will deploy also the network server with a PDU. So let's run that this recover infra first, and then the recover package. Basically, the recover packages, what is going to do is to add a repository here. Okay, the benefit catalog, and then upload to the system. Okay, the artifacts we need. Okay, Julia, what you don't have in the new machine? Let me check. Yeah, exactly. You have to launch with the recover infra. That is a script inside the folder HS script. Just run recover like this, recover infra, and then it will. Okay, and then recover package. We have here also in the HF script the NSI SH. It will be, if let's check it together. Okay. What this do is to get to create a PDU. Okay, for the slice. That is a requirement. Then it create the params slice.yml. That was the the file that we were checking before, where we want to influence the net slice.net. And here we have the orchestrator IP as the one IP that you need to force in the deployment, is this column. Okay. Then here in the proxy load balancer IP will be enforced as well. So we have here both for the param slice creation, and then it will trigger the command to instantiate or to create the network slice instance. So Maxma slice 1 will be our first slice, and it will use the Maxma slice Hackfest NST. That is something that is loaded by the package, and the script that onboard the packages. Okay, being account, we will use your OpenStack tenant and the file that was just created. Okay, we'll wait 15 seconds, and this is the optimization that I was telling you. Okay, so when we deploy the network service, you can switch to Juju and say, okay, please don't do the apt-get update and don't upgrade the image base. So with this optimization that we will run automatically with this script, then the Juju will not download the package from the operating system to put it operative. Also, just in case, we set a closest apt mirror in order to download quickly if something needs to be installed there. My script NSI NSI stage. Yep. Okay, don't worry if this command doesn't apply correctly. Maybe was removed the waiting here, and you was not able to create it in the moment. Okay. Okay, this is running. This is running. This is running as well. Okay, let's wait for the others. I will be supporting you by chat. So let me finalize with the next with the next scenario. So for the ones that could instantiate the network slice instance here. Okay. Then we will share this this first. It is located in the data center one. Okay, both, and the next magma net will be instantiating data center 2. Okay, so since it is shared, this net will not be reinstantiated, the Facebook magma. It will only be instantiated the gateway, but in other in the data center too. Okay, that's that will be the second part of the presentation, and also we will do with an optimization that is the placement algorithm, the placement algorithms to allocate automatically in the second data center. Thank you very much, guys. I will give you support by the Slack, okay, and the chat. Let's try to have everything running. Thank you.